Hi, this is Mohammed, and in this part of the assignment, I will be speaking to you about event-driven programming. So, event-driven programming. What is event-driven programming? Well, it is a means of programming in which, um, like the process is dependent on an event or an interaction. So, pretty much, this program would not run unless there's something that is pressed or done to trigger it. So it's not automatic, it does not work on its own. It needs the user's interaction. So pretty much this can be by mouse click, by a key press, or any other, depends on how it's programmed to do so, on what type of stimuli it is meant to respond to. So pretty much, once the interaction has been done, there's an event listener within the program. Once it recognizes the interaction, it it triggers, there's like a callback function. It triggers it and it sends a response to that stimuli, and which is known as the event handler. So this is basically what event driven programming means. Now I will tell you some key features of event-driven programming. Some of these features include events, event handlers, trigger functions, and also as well as predefined functions, local and global variables, parameter passing, modularity, time-driven, pro- tran- time-driven procedures, and programming libraries. Right. I will not be talking about all the key features, but I'll talk about some. So first of all, I will start with self-oriented. So self-oriented techniques are used so that different applications are able to reuse components. So pretty much different types of software applications can benefit from these services. For example, like so they can like let's say request data from a database. So this is pretty much like a little explanation on what self-oriented means. Next up, we got time-driven. Right, so time-driven programming is basically like it's a type of programming that is usually used in like real-time computing, where basically code executions is managed by the computer clock. So depending on the clock, there's certain commands that will be executed. So basically, this programming concept is like mainly used for safety critical programs because, the performance of these programs are highly deterministic. So, which kind of makes it very efficient. Next up, we got event handlers. So basically, event handlers are like, basically, they're made in code to determine what happens if the user were to do something with certain like buttons or like bars or whatever it is, you know what I mean? So pretty much, basically, when a button is clicked, like by the mouse or something or by the keyboard, the event like this event gets handled by the event handler and then gives a response to the button that has been clicked. Right. So next up we got modularity. Modularity is basically a technique that is used to like within software design. Um, Basically, it's used to kind of emphasize the functionality of the program into separate interchangeable modules. So basically, so basically, each of the modules now will contain everything that is necessary to execute a specific aspect of a particular function. So this is like the whole point of using modularity. Next up, which is last one, which is going to be programming libraries. Right, so programming libraries, or also known as event libraries, are basically like libraries that contain like usually things that are used a lot by the program, like routine stuff. So things like I don't know, like source codes, templates, fonts, scripts, etc. All these things that are just used regularly. So these can be like this can be used to like help users work more efficiently and also quicker because if it's already there it will be faster, because also you can utilize the functions that are built within the library, so you can work with it to carry out whatever you need. Now this part is going to be the merit criteria. Right. So pretty much, an operating system can be referred to as an event-driven program because basically, it is used to like open application and do certain things, like and perform certain actions with on the computer. And as you know, without an operating system, the computer is literally like a brick. You cannot really use it. You can use it within the BIOS, but that's just BIOS is very limited to certain things. So there's not a lot of things you can do on it without the operating system. So the operating system like has an event listeners and basically to keep track of any interactions that could happen within the operating system, so it gives a response accordingly to whatever you do on the system. So basically a simple example of this, if you want to open a browser like let's say Internet Explorer, Firefox, Google Chrome, you click on the icon, double tap it, and like the browser opens. So you got the event, which is the the icon browser, and then the response, which is the like it opening, which is by the event handler. Right. Another simple example is with like when you set the computer to sleep after a specific time. So pretty much this I would say I think it will be the time driven. So pretty much it would watch the it will be monitoring the clock of the computer, and once it counts let's say 5 or 10 minutes from the time that you left it inactive, it will automatically like put itself to sleep, and then to wake it up you just press on the power button or move the mouse or something. So pretty much this is kind of like all event driven. So right, one last example would be when you like drag and drop icons like or certain programs. So you just click and hold the icon, hover around, and then drop it somewhere, where basically, so pretty much the event is the initial click and hold of the icon, and then like dragging the file around, and basically the response is the file being added to like somewhere like where you put it, the different place or within a folder or within the C drive, I don't know, depending on where you want to put it. So pretty much these are a couple of examples of like how operating system is an event-driven program. Right now I'm going to be doing the distinction criteria, which is the suitability of event event-driven programs on non-graphical applications. Right. So pretty much for non-graphical event-driven programming, it can be used on Windows. It is possible, but the problem with that is it's not really very practical with everyday use because pretty much as you know, Windows is a graphical version, like graphical interface. So pretty much a graphical version would be more beneficial and could be used more, but it's still possible. We just need someone that knows their way around computers to kind of get that, like to be able to use, that non-graphical event-driven program. Right. Alarm clocks or alarm systems are a very good example of non-graphical programming. So pretty much, most alarms tend to not have graphics. Maybe the modern ones do, but the old ones really don't. It's kind of like, certain buttons you press on it, you could be able to carry out. So let's say if you want to set an alarm, there's usually like a little thing at the back that you roll, and then you could set the alarm. So pretty much the event is you trying to set the alarm, the result is the alarm going off once the clock arm hits the desired time. So pretty much it's like this is one of the basic event non-graphical event driven programming. Another example would be DVD players. So pretty much DVD players, they don't really need graphics or anything. Some of them have this little screen that says like stop, play, and all this, but it's not really like graphics. Graphics is just kind of showing the commands that you do. So pretty much really the it's all like the user will be able to control everything without using any graphics because the buttons kind of giving up the full control over the DVD player. So this is a good example of non-graphical programming. So you got the event, which is you, let's say, trying to play a disc, you press on play, and then the response is the disc starts to play. Right, another great example as well is the washing machine. Like washing machine is a great way to explain event-driven programming. There's literally some. maybe the new washing machines do have a screen which you could count as graphical, but the good old washing machines have no screens whatsoever, and it's literally the most basic event driven programming ever. You choose a certain setting and it triggers, the function within the washing machine, and then it kind of finds out how long it's going to take. It shows you the time, you press the start button, and then the response would be the washing machine will start going. So pretty much we use this in any every in a lot of our day-to-day lives. And so yeah, pretty much this is it for task one, and I will see you all in the next one.